Hi, I'm Mrs. Burns and welcome to Lesson 7 of our chemistry unit. Today we are naming compounds again, but we are naming covalent compounds. So let's review a few things about naming. First of all, ionic compounds are different from covalent compounds. Ionic compounds are between metals and nonmetals, and the electrons are actually transferred from the metal to the nonmetal. You can see right on your periodic table which ones are metals and which ones are nonmetals. It's divided for you. Covalent compounds, therefore, are between two nonmetals, and the electrons here are shared. We can draw Lewis and Bohr diagrams for both ionic and covalent compounds. Covalent compounds are also called molecules. So you might see this throughout your textbook talking about covalent molecules. That's just the same thing. We learned a couple lessons ago that multivalent metals can form ions in more than one way, and that polyatomic ions are made up of more than one type of atom joined by covalent bonds. So what we'll be looking at today. The whole group for a polyatomic ion has the positive or negative charge, not the individual atom. So there's a quick review. Let's dive into today's topic. The big thing I'd like to point out, I put it in a box, I bolded it in capital letters, so please take note that for ionic compounds, we would reduce the subscripts because we wanted to know the ratio of the ions. So for example, zinc 2, oxide 2, that doesn't work. We just say zinc oxide because we just want to know how many zincs compared to oxides. It doesn't matter how many, just what is compared to the other. So this is incorrect, and the box here shows us the correct way to write the formula for zinc oxide. For covalent compounds, however, we do not reduce the subscripts. Don't do it. Highlight that. Covalent molecules tell us the exact number of atoms of each element in that molecule. So H2O2, for example, hydrogen peroxide, tells us that there are 2 oxygens and 2 H's in that molecule. So here I'll draw the Lewis diagram for hydrogen peroxide. We need to know exactly how many to draw, so for a covalent compound, you tell us in the subscripts how many there are. So we're going to focus today on naming binary covalent compounds. So we're just talking about 2 different nonmetal elements, so like 1, 2. One is carbon and one is hydrogen, for example. And they're going to be bonded together, but there could be more than one of each. We could, for example, have C6H12. So there's 6 carbons and 12 hydrogens, but there's still only 2 types of elements. So we're going to use prefixes to tell us how many there are of each element. Let's take 6, for example. 6 is hexa. So that's the prefix for 6. And there's a whole list in table 4.13 on page 194 of your Science 10 textbooks. And this is very important that you get very familiar with these words and be able to use them really easily. So 6 is hexa for the prefix. So this would be hexacarbon, for example. So let's get into these steps. What do we do? How do we do it? Well, the element that is most left in your periodic table is going to be written first. So for ionic compounds, we knew metal always written first, nonmetal second. Well, in this case, you're going to have to look, since they're both nonmetals, which one goes first? Look at your periodic table. Whatever is closer to the left goes first. So for the example here, carbon or oxygen, which one is more on the left? I hope you chose carbon. The second element then, its name changes so that it ends with IDE, ide. So chlorine would go to chloride. That's really convenient because that's the same as what would happen with ionic compounds. Now you may notice that the second molecule in both cases is a nonmetal, so that's why they stay the same. The third step then is to add a prefix to tell us how many atoms there are of each element. Now, let's take a little skip over to the box here. The names are often reflective of what the prefix is. So N2O4, 2 is di, nitrogen, 4 is tetra. So dinitrogen tetraoxide tells us that there are 2 nitrogens and 4 oxygens in that molecule. However, sometimes it's not the case. For example, C2H6O isn't dicarbon, hexahydrogen monoxide. Unfortunately, it has a special name, ethanol. So there are some special names that you're just going to have to memorize or look up on the internet. Now, there are a couple rules for this mono for number 1. Often, we're not going to mention it. So, for example, let's say CO. So here we have the first one. There's just 1 carbon, but we're not going to do not put mono for the first element. So you just leave it normal carbon. Any other prefix you would put, but just not mono for the first one. But you will write mono for the second one. So this O here is all by itself, so it's going to be mono. However, for the special case of oxygen, we're not going to say monoxide. You just say monoxide because it's easier to say. Monoxide. And then you don't have 2 O's in a row and it just kind of looks funny. So why don't we practice a few here? Some examples. Here we have 2 nitrogens, so di is our word for 2, so dinitrogen. And there's just 1 oxygen, so we're going to say monoxide. Make sure you end with that IDE. Here's our prefix, and here's our prefix. All right, let's try the next one. Again, P is all by itself, so we're just going to say phosphorus. Phosphorus, and there are 5 chlorine atoms, so we're going to say penta for 5. That means 5, and then chloride. All right, ready for the next one? This one's a little bit more tricky because we haven't really seen this Xe element very much. So look them up on your periodic table and you'll see that it stands for xenon. And there's just 1, so no prefix in the front. And then this O here, oxygen, has 3, so it's trioxide. All right, let's try another. Sulfur. And 6 is hexa. Fluoride. Here we have 4 P's, so we're going to say tetra. Phosphorus. And now 10 stands for penta. Oxide. Great, and last example. Di for 2 chlorines, dichlorine. Now notice I didn't change the chlorine to chloride, even though it seems like you'd want to. You don't for the first atom, just the second one. And we have only 1 oxygen, so monoxide. All right, there you go. That concludes our section on naming. Please come to class prepared tomorrow to practice and also to take a deeper look at the differences between ionic and covalent bonds. Stay tuned for our next section on balancing chemical equations.